Okay, we're going to start with the answers to the homework from last lesson. And it's really important that you go through these answers just to make sure that you're getting everything absolutely right before next year. So, question number one, what did John Dalton propose about the nature of atoms and elements? So he said quite a few things, one of which was that all atoms in an element are the same. And that's the definition of an element. An element is when all the atoms in it are the same. So if you have gold, the element gold, it's made up entirely of gold atoms. Number two was that atoms in different elements are different. So if you have a piece of gold, that's made of gold atoms. A piece of iron is made of iron atoms. A piece of lead is made of lead atoms. And the third thing that we talked about last week was that chemical reactions involve combining, separating, or rearranging atoms. Okay, I haven't given myself very much space here, so make sure you're answering these in your book when you're doing them. Was John Dalton awarded a Nobel Prize for his contribution to science? No, he wasn't. So the first Nobel Prize was awarded in 1895. John Dalton was born in 1766, so he would have been dead for a long time before the first Nobel Prize was awarded. Now, you might be thinking that I'm giving you this historical background just out of interest. I mean, it is very, very interesting, all the stuff that we learned last week, but it's also very, very important. So you do need to know the history of the atomic theory. So all the things like Ernest Rutherford's experiment with the gold foil, you need to know and understand that. And you need to know about the contributions that different scientists make to the atomic theory. So it's worth putting things like that, not necessarily, you won't be asked, was John Dalton awarded a Nobel Prize? You won't be asked that. But it's things like, what did John Dalton say about atoms and elements? That kind of thing should go on a flashcard. What is the overall charge of an atom? That's 0, or you could put neutral, obviously, because the number of protons is equal to the number of electrons, and protons are +1 and electrons are -1. If a proton has a charge of +1, an electron has a charge of -1, and a neutron has no charge, what can you say about the number of protons and electrons in an atom? So they are equal, as I just said. Okay, because in order for the atom to have no overall charge, the number of +1 charges and the number of -1 charges must be equal. What is an isotope? Isotope are atoms, so it has to be more than one atom. Atoms with the same number of protons but different numbers of neutrons. Give an example of two atoms which are isotopes. So there are many examples you could have chosen for this one. You could have chosen carbon-12 and carbon-13. Or you could have chosen chlorine-35 and chlorine-37. Those are just two of the ones that we've spoken about. Name and describe the model of the atom proposed by J.J. Thompson. Okay, so J.J. Thompson proposed the plum pudding model of the atom. And that was this, so I've asked you to name and describe, so you just name it as the plum pudding model and describe it. You just describe it as a cloud of positive charge with electrons stuck into it. All right, and that's sufficient for that. In Rutherford's experiments, 3 different observations were made. Explain each one. Okay, so you remember that last week we did do this quite complicated discussion of Rutherford's experiment, and you will do this again next year. And I know this is quite tricky, but it's good if you to get a head start on the understanding of this. So these three observations each have an explanation. Most alpha particles went straight through the gold foil. So most alpha particles go straight through, remember this is the gold foil here, go straight through the gold foil. Okay, that means that so the atom is mostly empty space. So if most of the atoms go straight through, atoms are mostly empty space. Number two, some alpha particles were deflected from their path. Okay, so these guys here, some were deflected from their path. That means there must be a positive nucleus because remember the alpha particle is positive, and if the nucleus is positive, they're going to be deflected, like I had in this diagram here. Yeah, this is positive, and so there's a deflection because the same charges repel each other. And number three, a tiny number of alpha particles rebounded back. So that was these guys here that hit something and then come back. And it's like, well, you know, if they're being rebounded back, they must be hitting something. So what is that thing that they're hitting? Well, it must be really, really small because only a few of the particles are being rebounded back. Okay, but it must be quite a lot of mass in there. All right, and so the nucleus must contain most of the mass of the atom is what we can deduce from that. Okay, where is most of the mass in the atom found? So we just did that. That's the nucleus. What is the chemical symbol for the element sodium? That is Na. And you can find that in the periodic table here. This is my very messy periodic table that I've been using quite a lot. I don't think I have another copy. No. All right, so you should be able to see that this, I'll write it again, it's 11 Na23, which means that the 11 here, that tells you the number of protons, and 23 tells you the number of protons and neutrons. So, how many protons and electrons are in an atom of sodium? 11. Because remember, the number of protons is equal to the number of electrons, and that's why atoms are neutral. A pupil thinks he can make a positive sodium ion by adding an electron. Why is the pupil wrong? Well, an electron has a charge of -1. So, if I add an electron, if I add this -1 charge to something, it won't make it positive, it will make it negative. All right, and that's the reason. It's as simple as that. So anything here such as adding electrons will make it negative, not positive. What is the key difference between the models of Rutherford and Bohr? Okay, and that is that in the Bohr model, we have this idea of electrons in orbits or shells. Okay, so rather than just around the atom, they're in these defined areas. Atoms of a size of about 1 × 10 to the -10 meters, which is bigger, an atom or an animal cell? It would be an animal cell. Okay, so I know animal cells are very, very small, but atoms are, you know, it's difficult to imagine how small an atom is. And I've asked you here how many times smaller. So you'll remember that an animal cell is about 10 micrometers. Okay, now you'll remember that a micrometer is times 10 to the -6 meters. All right, which is equal to 1 × 10 to the -7 meters. Okay, so what I've done here is instead of writing 10, I'm going to write 1, and then instead of -6, I write -7. Now, this use of standard form here, you will have done in maths, but you will cover it again next year in science to become more familiar with how it works. All right, so we can see that if I was to do 1 × 10 to the -7 divided by 1 × 10 to the -10, I would get 1,000. Okay, so you have to remember that this is the smallest animal cell. The smallest animal cell will be 10 micrometers, and that's 1,000 times bigger than an atom, 1,000 times. So that's not an exact calculation, so you'll need to remember that, you know, for a lot of cells, it will be actually much, much bigger than that. in biology, we usually use microscopes with a 40 times objective lens and a 10 times eyepiece lens. Do you think you'll be able to see an atom with this microscope? No, okay, because that's going to give you 400 times, okay? And we need to use the 400 times microscope to see the animal cell. But the atom is 1,000 or even more than that times smaller than that. So no, you wouldn't be able to use that kind of microscope. An atom of fluorine has 9 electrons. How many electrons does a fluorine ion with a charge of -1 have? Okay, so you'll remember that atoms gain electrons to give a negative charge. Okay, so if an atom of fluorine has 9 electrons, then an ion with a -1 charge will have 10 electrons. An atom of magnesium has 12 electrons. How many electrons does a magnesium ion with a charge of +2 have? And you'll remember it's the opposite of positive charges. So if I lose an electron, I get a positive charge. So to go from 12 electrons to a +2 charge, I'll have 10 electrons. Okay, which is interesting because it means that a fluorine atom with a -1 charge and a magnesium atom with a +2 charge have the same number of electrons. But we'll do more of that next year. Nitrogen-14 has a total relative mass of 14. How many protons, neutrons, and electrons does an atom of nitrogen-14 have? Well, nitrogen in the periodic table is here. Okay, and you can see its atomic number is 7, which means that it has 7 protons. Okay, and the relative mass, 14, is the number of protons and the number of neutrons. So that means that I must have 7 neutrons. Okay, we don't worry about the mass of the electron because the relative mass of the electron is so small, but I know that in an atom, the number of protons is the same as the number of electrons, so I have 7 electrons as well. What is the relative mass of an electron? 0.0005. And using the answer to the previous question, explain the term relative mass. Okay, that means that the mass of an electron is 0.0005 times the mass of a proton. Okay, excellent. So on to the next video where we finish off this bit on physics.